Gautam?
Join start பண்ணிக்கிட்டு இருக்கேன்.
Yeah, can someone? Oh, you have started recording. Okay, all right. Okay. So, see, actually, I thought that only people from Tamil Nadu will be coming. So, but unfortunately, we have people from all over India. I think we have Bhavika's from Delhi. Anyone?
Just
I think she's
ignore
only.
Bhavika.
Yeah. Who else? Yeah, she's from Delhi. Other Darshana, Gautam, Iman, Vigneshwari, all of you are Tamil, right? Vishal also Tamil only. So I mean, at least we have one non-Tamil speaker. So I have to I have to take the class only in English. So I'll just take it in English itself. Okay. So I'll be taking like 30 minutes class. Okay, because we have to go to next class at 2 o'clock. So what we'll understand is, see, what ma'am has done is she has taught the complete Eigen vector concept without any visualization. Like she just said this is a vector. She just said this is vector. But she didn't say how this is a vector. Vector means it should be a start and fixed end point, correct? But she has not told how it is a vector. That is the entire problem. We have not done any visualization. That is why we have many confusions. So my task is I'm going to do a complete visualization of whatever we have learned. Then you will understand everything. So first thing we'll understand is Ax equal to b. This system. The system, we have to start with the system. The system I'm only going to discuss for 3 by 3. So this is a 3 by 3 matrix. This is a 3 into 1 matrix. And result will be 3 into 1 matrix. Only for this system we won't discuss. So how to find solution for this? First of all, what is x? X is nothing but you're having a point. This is a point. So whenever they give a 3 equations, they will write in matrix format and we'll try to find the point. Now how we'll find the point? We'll write Ax equal to b. We'll take A inverse on both sides like this. And now A inverse into A will become I. And then I into x will be x. So like this we can get the solution. We can get the solution like this. But the problem is, this is unique, right? This is unique. This is unique. Obviously this is also unique. But the problem is, does A inverse exist? Does A inverse exist? It may or may not, right? So when does A inverse exist? If determinant A is not 0, A inverse exists. If determinant A is 0, then A inverse does not exist. So if determinant A is not 0, then x is a unique point. Meaning 3 planes are there. 3 planes, they intersect at a unique point. Okay. But if determinant A is 0, then no unique solution is there. So what we have to do is, we have to analyze in depth this case. This case only has lot of visualization, which I'll be giving now. So what we'll do is, we'll split the entire thing into 2 parts. We are having Ax equal to b, like this here. If determinant A is not 0, then you are having unique solution. If determinant A is 0, then we won't have any unique solution. Now this is further split into 2 parts, that is no solution, another is infinite solution. No solutions are of 2 types. One is planes are parallel. If planes are parallel, then they cannot have any point of intersection, so there is no solution to the system. Or they form a prism. I'll draw everything and show for you to understand. Infinite solutions are of 3 types. One is 1D solution, that is line. Another is 2D solution, that is plane. Another is 3D solution, that is space. All this is actually part of JE. But to understand Eigen vectors, we need to understand these points carefully. Yeah. Is it clear till now? Someone, just one of you respond now, so that I can get to know whether you understand.
Yes, it is clear.
It is clear. Okay. Any doubt, you please unmute and ask. Okay, I'm ready to clear any doubt. So, see what is prism solution? Prism means you are having something like this. You are having one like this. This is one plane. This is other plane. This is another plane. See, this is one line of intersection. This is another line of intersection. This one. And this is another line of intersection. They don't meet. No line meets. So that means there is no solution. If you're having 1D solution means, it's a line solution. Now when will line solution be? If the planes are like this, you're having one plane like this, you're having the other plane like this, you're having another plane like this. This is a common line of intersection. Common line of intersection. Best example is notebook. You're having notebook, you all take your notebook, and if you see, each page is a plane. Each page is a plane. And they all intersect, all have a line of intersection. So all the points situated on that line is a solution to the given set of equations. If it is a 1D solution. If it is a 2D solution plane, what does this mean is, this is the case wherein all three equations are actually same. All three equations are the same. The example, suppose I'm giving you x plus y plus z equal to 1. I'm giving you 2x plus 2y plus 2z equal to 2. Minus x minus y minus z equal to minus 1. Actually, all these three are redundant. That's what ma'am said, redundant. Which means they all are actually the same. There's only one plane. That's it. This plane, any point on this plane is a solution. This is what you should understand. So, in this case, the entire 2D plane, this plane is x plus y plus z equal to 1. The entire plane is a solution. So, this is 2D solution. So, these three I have explained. Prism solution, 1D solution. 1D solution, this entire line is a solution. All points lying on this line will be solution. If it is 2D solution, that is all three planes are the same. Any point situated on this plane is solution. And 3D solution means it will be like this. Suppose you are having an equation. You are having 0x plus 0y plus 0z is 0. You are having this. Suppose you are having this system of equations. This means all points on 3D plane are solution. Any point to take on the 3D plane, it will be lying on this. Try and see, you will understand. All are solution. This is the only case you will have 3D solution. You should have 0x plus 0y plus 0z is 0. All three equations. That time only you will have 3D solution. Okay. So these are all the types of solutions that we have to understand. And first of all, try to visualize. I'll come to Eigen vectors. All this is connected to Eigen vectors. That is why I'm showing all this. Okay. Was it clear till now? Does anyone have any doubt on what I've just shown till now?
Yes, clear.
Any doubt? Please ask.
No.
Yeah, very good. Now we will be moving on to another system of equations. That is now what we are going to deal with. That is, suppose you are, instead of having b, if you are having, if b is 0, that is, you are having ax equal to 0 system. Ax equal to 0 system is known as homogeneous system. Now what is special about homogeneous system is that 0, 0, 0 is a granted solution. Definitely, if you see itself, you can say that yes, 0, 0, 0 is solution. That is why this solution is known as trivial solution. Look at, suppose I'm giving x plus y plus z is 0. I'm giving 2x plus 3y plus 4z equal to 0. And I'm giving minus x minus y plus 3z is 0. On seeing, you can just see your eyes, you can tell, right, the 0, 0, 0 solution satisfies. So this is called homogeneous system. Homogeneous system means you will have all constants 0. Definitely 0, 0, 0 is a solution. So what is the advantage of having homogeneous solution. If you are having homogeneous solution, if B is 0, then we know that 0, 0, 0 is always there, is always a solution. Meaning, this case won't be there. This case doesn't exist. Clear? You're having 0, 0, 0. This entire case you don't have to write because you know that anyway there is no solution. If you know there is no solution, then how can you talk that there is no solution? I hope this is clear. This is only difference. If you're having Ax equal to 0, this cases will not exist. You can have this case, you can have 1D, 2D or 3D solution. Okay. Now I'm going to proceed. So now only we have to come to the concept of characteristic equation. We'll come to this concept. Now, suppose I'm just giving you a question. Just giving you a question. Ax is equal to lambda x. See, first we try to understand what this is. This is a matrix. This is also a matrix. This is also a matrix. But this is not a matrix, this is a number. Okay. What I'll be doing is I'll bring it to one side first. And I'll take x outside. If I'm taking x outside, a minus, I can't say lambda, I say lambda I into x is 0. Okay. I should say a minus lambda I into x is 0. Now I'm asking you a question. The question is, find the values of lambda such that the given system of equations has non-trivial solution. This is the question I'm giving. Find the values of lambda such that the given system of equations has non-trivial solution. Now please come to this. I'm having Ax equal to 0. B is 0 now. If I'm saying B equal to 0, then there are two cases. One, I can have unique solution or I can have not unique solution. Now if I'm saying this determinant is 0, I'll have unique solution. If I'm saying it's unique solution, see, if now I'll take this entire thing as A dash. So I'm having system as A dash x equal to 0. If I'm saying if determinant of A dash is not 0, then it means I have a unique solution, which means I have 0, 0, 0 as only solution, which means I have only trivial solution. This is not allowed because the question I asked is find the values of lambda such that the given system of equations is non-trivial solution. So if I want to have non-trivial solution, definitely I should come over to this case. This case is not there for b equal to 0. I should come to this case, meaning I should come to infinite solution case. If I have to come to this case, it means I should cross this part, which means I should have determinant of a 0, which means I should have, so for non-trivial solution, I should have determinant of a dash is 0. And I should say what is determinant of a dash? A minus lambda I should be 0. This is how, and lambda values that you get, they are given a special name called Eugen values. That's all. Eugen values. Sorry. So are you understanding this concept? Is there a doubt on this concept? If anyone has doubt, you can ask.
No, bro.
All clear? So for non-trivial solution, I want some solution other than 0, 0, 0 to exist. If I'm having some determinant a dash not 0, then I'll have only unique solution. That will be only, trivial solution. But I want to have some system wherein I'm getting other answers other than 0, 0, 0. That is why I am equating this to, that is why we are seeing this and we are saying this determinant should be 0 so that non-trivial solutions exist. And lambda we are giving a special name that is called Eugen values. Okay. Now we'll come to some concepts to understand more about Eugen vectors. Give me 1 minute. So please do some observation what I'm saying. Now we'll solve one question to enter Eugen map. Suppose I'm giving find the solution. Giving question, we'll solve this question. Give me 1 minute. Suppose I'm saying x plus y plus z is 0, 2x plus 3y plus 4z equal to 0, and I'm saying 5x